In this video, we're going to do a more conceptual example involving marginal analysis. So this is example 4, continuing our numbering of examples from the previous videos from this section. So the question is, suppose P of 72 equals 3200 and P prime of 72 equals -5, where P of X is the profit of selling X items in dollars. Part A of this question is asking, interpret P of 72 and P prime of 72. Include units in your answers. All right, so let's begin with P of 72 and what that tells us. So we know that as a number, P of 72 is 3200. But what are the units of this? P is a profit function, and it tells us that we're measuring profit in dollars. So this is in dollars, $3,200. And this is the profit from selling however many items we're talking about. So the number of items we're talking about is, in the general formula, it's X. And X is what we plug into the function, what's in the parentheses. So here we're plugging 72 in. So we're talking about the profit from selling 72 items. Okay, so that's one part of what this question wanted. It wanted us to interpret P of 72, and now we've done that. Okay, so let's do the next part of this question. Let's interpret P prime of 72. All right, so P prime of 72, just as a number, that's -5. So what does that mean? What does that mean? This means that, so this is where I'm going to draw a picture to help us illustrate what's going on here. Okay, so I'm going to draw some axes. So I got my y-axis and I got my x-axis. So in this case, the x-axis represents the number of items, x, and the y-axis is going to represent the profit, p. So at some point, we have the x value 72, and when x is 72, the profit is supposed to be 3,200. So I'm not drawing this to scale, just so I can fit this picture in, but 72, 3,200 needs to be a point on the graph. And the problem tells me that whatever my profit function looks like, the derivative at this point needs to be -5. So that means the slope of the tangent line needs to be -5. So when I draw a rough picture of the curve at this point, our curve needs to be sort of angling downwards. If it's angling downwards, now when we draw the tangent line, so it matches the slope of the graph here, the slope of this tangent line, needs to be -5. Let me write that a little bit better. Needs to be -5. And one of the things that tells us is, if we go from where x is 72 to where x is 73, and we use the tangent line to sort of approximate what's going on with our function, because we don't know what the function really looks like. We just know the slope of the tangent line at this point, and then the y value at this point. We don't know any other information. So if we use the tangent line to sort of approximate what's going on with the original function, if I draw a vertical line and then a horizontal line, and if I do a rise over run thing, so we know that this run is 1. That's the distance from 72 to 73. And because the slope of this tangent line is -5, that means that vertical distance is 5, but notice that my tangent line dropped sort of 5 units in the vertical direction. So what that tells us is that we would approximate that the profit will decrease. It will decrease by $5. That's how much the y value went down. By $5 from increasing the number of items sold from 72 to 73. So if we increase the number of items that are sold by 1, we would approximate, using our tangent line, that would decrease the profit by about $5. Okay, so that's what the derivative tells us. That's the interpretation of the derivative's value. It's an approximation of the change in our function. Okay, so on the flip side of this, what this also means is if the business were to decrease the number of items sold from 72 to 71, so if they were to go in the other direction, so from 72 to 71, we'd sort of approximate, where's that point on the tangent line? It's higher. We'd approximate that by decreasing the number of items sold from 72 to 71, that the profit would go up by $5. Okay, so the business should, as a result, should probably sell fewer items than 72, since the number I forgot a word there. Since decreasing the number of items sold from 72 to 71, from 72 to 71. So if we decrease the number of items sold by 1, so from 72 to 71, we drop it by 1 item, this would approximately increase the profit by $5. So those are sort of the two sides of this tangent line. Because it's trending downwards as a slope of -5, increasing x would decrease the profit, but decreasing x would increase the profit. At least that's what we approximate based off of our tangent line. So here is part B of this example. It's this true or false question, and it's saying that P of 73 is less than P of 72. In other words, the profit from selling 73 items is less than the profit from selling 72 items, and we want to justify our answer. So I want to have you all pause the video for about 2 minutes to really try this question on your own first. 4, 3, 2, 1, pause the video. Pause the video for about 2 minutes to try this on your own first. And one thing that might help is drawing a picture, kind of like we had above, and thinking about, will this be true or no? Can I come up with a counterexample? All right, so hopefully you've done that. Hopefully you've paused the video for about 2 minutes to really try this question. All right, so let's talk about it together now. So I'm going to draw a picture again. So I'm going to draw my axes. And when x is 72, so on my x-axis and the vertical one's the profit axis, when x is 72, the profit is 3,200. So I have a point here. And I know that right at that point, the graph is trending downwards. So whatever it looks like, it's sort of curving downwards. And if I draw the tangent line right at that point, the tangent line matches how steep the graph is right at that point. This tangent line has slope -5. So what I want to know based off of that is, if I think about where x is 73, will the profit at 73 definitely be lower than the profit at 72? Or in other words, wherever the point is on the graph at 73, so whether the point is here or somewhere else, so wherever the point is on the graph when x is 73, is that point definitely going to be lower in terms of the y value than the point where 72 is? Okay, so I'm going to draw this in the picture and then I'll write it out in words. So I could definitely have a scenario where the point at 73 is way up here, because maybe my function just quickly changes direction, boom, and then does that sort of thing. So maybe it's just decreasing ever so momentarily, but then it just rapidly changes direction and gets higher. So we've just drawn a counterexample. This is false. This is false. Even though p prime of 72 is negative, even though the derivative at 72 is negative, the graph of p could quickly change direction so that p of 73 is greater than p of 72, as in the counterexample on the right, as in the counterexample. Okay, so drawing a picture is a great way to show what our counterexample would be. So the key takeaway from this is the derivative, and knowing what the derivative of our function is at some number, is just an approximation. It's just an approximation of the change in our function. In this case, we were talking about the profit function. So the fact that our tangent, our derivative here was negative 5, only approximates that we expect our function's value to decrease by 5 if we increase x from 72 to 73. We just approximate that. It doesn't mean that it has to be that way. And we just drew a picture where it wasn't. So often for these true-false type questions, it's helpful to draw a picture in terms of visualizing what's going on and then really thinking about, like, is it possible to draw my picture in such a way that I get a counterexample where I show that the statement is false. And we were able to do that here. All right, in terms of our goals for this section, we have now finished our 5th goal, which is doing a conceptual example. In the next video, we will begin our next section, 4.3, on the product and quotient rules. So we will learn some more derivative shortcut rules.